All right, so now I'm going to go over ecological footprint. Massively important concept in sustainability, especially from a natural resources perspective. So what are we going to think about as we go through this? What is ecological footprint? How can we use it to assess sustainable resource use? It's a really good way to do it. And then we were going to explore sustainable or unsustainable global ecological footprint and what that means. Okay, so ecological footprint, what does it mean? This is how it's defined in the video. The amount of land and water area. So this is really important, this first part. It's an area of land and water, right? So you kind of sort of visualize it down here. So that's what's really nice about this concept. It actually um, indicates a physical area. And if you think about what we've been talking about things so far, we're sort of like, well, don't overuse resources, don't emit waste too fast. Sustainability is this sort of like, how do we provide needs? It's all a little bit gray. What's really nice about this is a specific area. So acres, hectares, thousands of square miles, whatever. So how much land and water area, like human population, so it's scalable, would hypothetically need to provide the resources required to support itself and absorb its waste-giving prevailing technology. Okay, so it's a specific area of land and water so you can do this at any scale. From an individual, you can calculate your own ecological footprint, to a community, to a state, to a nation, to the world. Okay, and so how much would that population need to effectively provide all of its resources that it needs and absorb all of its waste? Again, this is sort of a recurring theme. How are we getting our resources and what's happening to our waste? So this is absolutely essential. So you want to write down that definition. Um, and this is really important. So make a note of this. This area of land is uh, can or an ecological footprint is an area of land that can continue to provide those resources. So basically, it's okay, the Earth has a capacity, for example, to absorb carbon dioxide. It can actually absorb quite a bit of carbon dioxide. But if you emit too much carbon dioxide, then what happens? Well, the CO2 levels go up. But you can emit a whole bunch of CO2 and the Earth will absolutely reabsorb that over time, and that you can actually emit CO2 and be sustainable. It's just if you emit too much CO2, you take too many renewable resources, okay? So that's really, really important to understand. It's not like we're taking up this much area and then you know, it sort of disappears or it's, you know, um, completely devastated. It's not like that. It's like how much can we use and of area of land that can continuously provide those resources. Okay, super super important. So some basic examples of things that add to human ecological footprint, and maybe you want to pause and think about what might do it. So from a consumption perspective, where are we getting our food from? What type of food are we eating? Are we eating seafood? Are we eating too much seafood? Are we it's not just you know, the physical area of, say, like corn or soybeans or apples or whatever. It's also, if I eat meat, how much area of land is needed for that cow to graze, or, you know, for that chicken to, you know, um, grow and so forth. We can look at water consumption. We can look at energy, particularly renewable energy sources. How much land does that take up? In terms of waste generation, the biggest one is really CO2, the huge part of our ecological footprint. But you know how much area is needed to landfill. I mean, you could look at that too if we're taking up otherwise bioproductive land. Okay, so the Global Footprint Network, very great resource. Some of the readings were from their website, but it's amazing, research based. They have all kinds of data on there. I highly recommend that you explore their site. And so they sort of simplify this as a supply versus demand. So I want you to think about, if we're trying to calculate whether or not we are sustainable, um, which is the supply for ecological footprint and which is the demand. And so The demand is that area of land that you need. So your ecological footprint or your society's ecological footprint. The supply is the biocapacity. You want to jot down that term, biocapacity. And so biocapacity is basically the biologically, how biologically productive is it? How many resources can it provide? And so this is it's I think if useful to think of it in these terms because then you can look at a basic like, all right, are we demanding more than our supply? Or in other words, is our ecological footprint more than the earth can provide? So that's actually a really good way to think of it. And this image actually shows you the global ecological footprint. Okay. And this is from 2025. And so again, this is from Global Footprint Network. And so in 2025, the total ecological footprint of all the people on planet Earth was about 21.7 billion hectares. HA is hectares, which is about, I think, like 2.5 acres, something like that. And so if you have this much total ecological footprint and there's 8.2 billion people, that's about 2.6. That's a demand, okay? So this is the demand per person in 2025, about 2.6 acres per person. And so how do we look at whether or not that's sustainable? Well, the demand, the total demand was 21.7 billion hectares, which is about 53.6 billion acres. All right, so that's what we needed to support our collective lifestyle globally. The supply is about 12.2. So you can see we have a problem here. Our demand is higher than our supply. So you can actually use these numbers to figure out how many Earths, quote unquote Earths, you would need to support the global population. So I want you to press pause and think about how you do that. And really all you need to do is divide. So you divide the demand by the supply and you get 1.8. What does that mean? That means we are using 1.8 more capacity than the Earth can provide. So we would need 1.8 Earths to sustainably provide our lifestyle. That's important. This is how many Earths we would need to sustainably provide all of the needs of the human population. So if we need 1.8 Earths, and if you do a little math, we only have one Earth, right? So what's going on? So how can we use more than we have? And the issue here is um, our demand is exceeding our supply. So what does that mean? So let's actually look at a chart. Maybe that'll help explain it. This is also for, again, global footprint network. Okay, so this is our global ecological footprint, aka our demand, right? So this is how much we need. This line here, and you can see it's getting bigger and bigger over time. And this is per person. This is not total. This is per person. Okay, so we're getting more, we need more and more per person. We're kind of leveled off, which is okay. The problem is that this is the global biocapacity. So this is your supply. So demand, supply. So you can see at what point did we start to exceed biocapacity? And you can see this is from 1965 through 2022. So right around here, this is where our demand line met our supply line. And so right around 1970, we were exactly uh, using the exact biocapacity as we demanded. Now the problem is after 1970, our demand, okay, exceeded our supply. So what happens? Like, how can we use more than our supply? Well, that's what this downward slope indicates. What does the downward slope of that supply line mean? That means that over time, we're actually, in addition to population growth, we are, we have less biocapacity because we're using up too much. And so that's what happens. I mean, we can for a time use have a higher demand than our supply, but that makes this line go down, which means that we are reducing the Earth's capacity to support humans because we're reducing that overall biocapacity. Okay, obviously not a good thing. And if you project this line forward, and we keep going down, that's, well, what you would call a problem. Okay, so we can also look at this at the national level. And here is the United States in 2022, the most recent data we have. Again, Global Footprint Network. This is saying that we have 3.8 hectares per person of biocapacity, but we're using 7.9. What does that mean? We're at a deficit of 4.1. So just like the world, we can look at how many United States we would need to provide our needs. Again, you divide the demand by the supply. So we would need 1.8 United States to continue to support ourselves. So what are we doing in the US? It's not just, this is not the exact same as globally, because even though we have a limited area in the United States, I want you to think about how can we get resources that we are not actually producing, and imports. We can import resources from other countries. At the same time, we are reducing our capacity over time. Now let's look at Canada. So here's Canada, a supply of 14.4 and a demand of 8.4. So they actually have um, a biocapacity reserve, which is indicated by the green area. And so Canada, actually, they would only need 0.6 Canadas to support themselves. So they're actually operating at a surplus, which means that they are maintaining their supply better, except that you can see that it is going down over time. Now, globally, again, here's that chart. It's at 1.8. Okay, so again, this is a very useful metric. And you can actually look at the lifestyle. So for example, we can do this quickly on the fly. So this is our demand in the United States, 7.9 hectares. So I want you to think about the fact that globally there's 1.5 hectares per person. So I want you to think about how many Earths we would need if everybody in the United States or everybody in the world lived like the average American, who demands 7.9 and the supply is 1.5. So I'll let you do that, and I'll leave that for a quiz question at the end of the week. So think about that. Okay, so I want you to think about what's a sustainable ecological footprint. Kind of hammer this home. All right. So let's look at this chart. So this on the this axis here, right, our y-axis is the percent of global natural resources left. So it doesn't matter. You can take any point wherever you're watching it, whenever you're watching this video, excuse me. So we're starting at 100%, right? We're starting where we are. So let's think about if we have ecological footprint of exactly one Earth. So what does that mean? And let me draw 3 lines here. This is technically a straight line. Shouldn't go down. This is a line going up, and then here's your line going down. All right, so there's the 3 lines, and these are 3 scenarios right here. Okay, so one Earth, greater than one Earth, less than one Earth. So this is all the people on the planet. So I want you to think about which of these scenarios each of these represents. So ecological footprint of one Earth. Which of these 3 lines does that indicate? So I want you to press pause and think about that. So if we have one Earth, remember that is the amount of land and water we need to continue to support ourselves. So if we are at exactly one Earth, we're actually at this line. We're level, we're sustainable, at least from a natural resources perspective. Okay, because we're using exactly the amount the Earth can renewably provide. Now, for greater than one Earth ecological footprint, what does that mean in terms of the line? Are we going up or down or across? So we're going down, right? Because we're actually using more resources than the Earth can continue to provide. Okay. And then lastly, if we are less than one Earth, right, we're actually going to increase our overall biocapacity over time, which is really good. And that would be the ideal scenario. So from a strictly natural resource sustainability perspective, we can have exactly one Earth and we're going to be okay. We're not going to overuse our resources in total. Now, you think about it, individual sectors, right? So maybe that means we've gone net zero and there's no net carbon emissions. So the emissions went down, but maybe we're using more land for food. So it's sort of it could all balance out, right? So that doesn't mean every sector is sustainable, but technically we're at least not overusing their resources. And then, of course, if we're using less than one Earth, that's the best case scenario. And then we're actually increasing our biocapacity. Okay, so let's look at a few um, questions here. So ecological footprints can be calculated at any scale. True or false? That, of course, is true. That's great. Individual, state, country, whatever. Which of the following can be aspects of an ecological footprint? Okay. Carbon dioxide emissions? Absolutely. Huge part of our footprint. Wastes produced? Yes. Types of food eaten? Yeah. Meat versus vegetables, different kinds of meat, seafood, etc. Paper products, is that part of the footprint? Absolutely, right, because that comes from trees. So now maybe that's renewable, for recycled products, in which case um, it really doesn't count for ecological footprint except for any energy that's used. True or false? Biocapacity refers to the demand side of evaluating ecological footprints. So biocapacity, remember the resources that the earth provides. Is that the demand or supply? That's the supply side because it's what the earth supplies. When true or false, when supply exceeds demand, ecological footprint is unsustainable. So we have more supply than demand. That's actually a good thing. That means the biocapacity is greater than the demand for biocapacity. All right, so that's actually sustainable. Again, at least from a overall natural resources perspective. And then finally, which following are sustainable global ecological footprint? More than one Earth, not sustainable because we are demanding more than the supply. Less than one Earth, of course, that's sustainable. And then exactly one Earth, remember, that's actually okay because that means we are demanding the exact same amount of land and water that Earth can continue to provide over time. All right. So hopefully you have now answers to these questions. And I want to leave you with one other thought. Remember that ecological footprint is a cumulative, it's a combined metric. In other words, we're looking at land needed for food, land needed for wood and other natural resources, cropland, land for water, and then land, for absorbing our carbon footprint and so on. So we're combining all those into one. And so you can actually be okay when one, like let's say we're carbon neutral and we're not emitting any more carbon than your Earth can absorb, but we're using too much land for food, right? So it's not necessarily that every individual sector is being used sustainably, but the overall land and water. So it's a really good metric. It's not um, there is some lack of detail when you look at the individual sectors within the metric, but overall, it's a really good way to think about whether or not we're using our renewable resources sustainably.